Welcome to today's lesson. We're going to be talking about balancing chemical equations today. All right, and so we're going to take those types of reactions that we talked about, and I'm going to show you how to balance them. And the reason that we balance them, this guy right here, Antoine Lavoisier, he came up with kind of this law of conservation of mass. And what he did was he showed that in a chemical reaction, everything, all mass that was on one side of the reaction is conserved, is still present on the product side. And so mass is not lost. He was able to trap gas and liquid and stuff like that, and after a reaction has occurred, to show that every bit of that mass had been conserved from one side to the other. And so when we balance the equation, what we're doing is we're proving this law of conservation of mass. We are showing that the mass is conserved. And so when we balance these equations, we're showing this. So basically, if we have two carbons on one side, we need to end with both carbons. And a good example here is the graham crackers. So we have 2 graham cracker squares, 1 marshmallow, 3 chocolate squares. And so this is the reactant side of the equation. On the product side, we have 1 s'more. Okay. So we have the same amount of mass on this side as we did on this side. It's just combined into one thing. As here, they were each separate elements, okay? And these elements combined into one compounding structure. And so the reactants and products are always going to equal out in the end. So here's how we balance is we use what are called coefficients, okay? So I highlighted these in orange for you. The coefficients are bigger numbers that are going to be placed in front of the compounds or elements inside the equation. Okay, so they're not going to be these little numbers here, these subscripts. Those tell us how many atoms, say, of hydrogen we have. This outside the parentheses tells us we have 3 sulfate ions. So we're not changing these subscripts. We can't change these subscripts. For example, if we put a 2 here next to H2O and that becomes H2O2, that is no longer water, it is now hydrogen peroxide. So changing these subscripts completely changes what we're dealing with and what element or compound or whatever that we are talking about. Okay, so we can only add coefficients to balance an equation. And so what these do is they multiply by those subscripts to tell us how many atoms of that particular element we now have inside the compound. So here, 2 times 1 tells us there are 2 hydrogen atoms. Okay. Here, 2 times the 2 down here tells us now we have 4 hydrogen atoms. The 2 times this 2 down here tells us we have 4 hydrogen atoms, but it also multiplies by the oxygen, the 1 on the oxygen. So we also have 2 oxygen atoms. So these coefficients, they don't just multiply by the one element or the first element, they multiply by everything inside that compound, okay? And then another compound will have its own coefficient. Now this one tends to get a little confusing for some people. This is a sulfate ion. So we're not multiplying the 2 by this 4, okay? The 4 is part of the sulfate ion. Sulfate is SO4. Instead, we're multiplying the 2 by the 3 out here because initially we had 3 sulfate ions. But if we multiply the 2 times the 3, now we have 6 sulfate ions. All right, and so that's how coefficients work. They're going to be multiplied by these subscripts as we go through. All right, so here we have an unbalanced equation. What we have is we have a compound called hydrazine. This is kind of a colorless, odorless, not odorless, but it's a colorless, flammable liquid. It kind of smells like ammonia, so definitely not odorless. But It's also highly toxic when handled, so this is something you don't really want to play with. But anyway, so we have hydrazine reacting with oxygen gas to produce nitrogen gas and water. Now this formula here, or this equation, is unbalanced, and let me show you why. So if we were to break down each of these individual elements inside the equation, we can see that on this side, on the reactant side, we have 2 nitrogen, 4 hydrogen, and 2 oxygen. Okay, so hopefully you guys can see where I'm getting these numbers from. Up here we have 2 nitrogen, we have 4 hydrogen because of the subscript here, and 2 oxygen. So when we're breaking it down like this, we have to add up all of the elements that are on the reactant side, and then over here all the elements that are on the product side. Okay, so speaking of, on the product side, we have 2 nitrogen, we have 2 hydrogen, and we have 1 oxygen. All right, now when you look at it this way, you can see that the nitrogens both balance out. The hydrogens do not, but the oxygens do not as well. Okay, so nitrogen is the only thing that are balanced. So here what we can do is we can start with hydrogen and try to balance that out. And so since we have 2 here and 4 here, we know that if we maybe multiply by 2, so we can try putting a 2 here. 2 times 2 equals 4, right? And then that also gives us 2 oxygens. Okay, so we're multiplying the 2 by that 1 oxygen, that gives us 2 oxygens. So just simply by putting this coefficient here, we have balanced the whole equation. Now we have 2 oxygens on both sides, we have 4 hydrogens on both sides, and 2 nitrogen on both sides. All right, so let's look at another example. This here, this is a single replacement reaction, okay? So when you're going through, just kind of look at it and decide what type of reaction it is, so you continue to get that practice on. Oh, and by the way, what types of reactions we're looking at. So now looking at this one, we have copper and we have oxygen gas that combine together to create copper oxide. This is a synthesis reaction. Or addition, so you can write it either way, synthesis or addition. Okay. All right, so now what we want to do is we want to balance it on both sides. So on this side we have copper and we have oxygen. We have 1 copper, we have 2 oxygen atoms. Over here we have copper, there's only 1. We have oxygen, there's only 1. All right, so now we want to get this oxygen over here to balance with this oxygen over here. So these oxygens are not balanced. So what can we do? Where do you think we can put a coefficient? Well, I'm going to start right here, put a 2. What that's going to do is that's going to now give us 2 copper, okay, because 2 times 1 equals 2, and it is going to give us 2 oxygen. All right, great, so now our oxygens are balanced, but our copper is not. So what we can do in this case is we can just come back over here and put a 2 in front of copper. Now it gives us 2 copper. And this is a balanced synthesis reaction between copper and oxygen gas. All right, next example. This is another synthesis reaction. Between aluminum and chlorine, okay, or chlorine gas to produce aluminum chloride. All right, so let's break it down. We have aluminum, there's only 1. We have chlorine. There's 2. And then it produces aluminum. Only 1. Chlorine. There's 3. All right. So this one seems a little more complicated. We have an odd number over here, and we have an even number over here. So we have 3 chlorine atoms on the product side, 2 chlorine atoms on the reactant side. So how are we going to balance this one? Well, the easiest way usually is to balance that odd number, because you're not going to be able to balance an even and odd. So try to create an even number is the easiest way to do this. So I would start over here by adding a 2 here, and I usually start with a small number and see if that works. I don't jump too high right away. If you start with a small simple number like 2, then you can see how that works out. So that's going to give me 6 chlorine, but it's also going to give me 2 aluminum, right? Because the 2 times the 1 aluminum, and then the 2 times the 3 chlorine. Now how do we get 6 chlorine on the other side? Well, we're going to go ahead and put a 3 here. 3 times 2 gives us 6. But now the aluminums are off balance, and so we have 2 aluminum this side. All we have to do is place a 2 here. There you go. So adding these coefficients of 2, 3, and 2, we have now balanced this reaction, and it shows that we have conserved mass on both sides. We have 2 aluminum on both sides, 6 chlorine on both sides, and we see that the law of conservation of mass has been fulfilled, and we have balanced this equation. All right, so now let's look at another one. Here we have H2O2, which is hydrogen peroxide. Okay, so we have a compound on the one side that breaks down into a smaller compound in an element. So breaks down into water and oxygen gas. So if it's breaking down, then we know that this is a decomposition reaction. All right. So once we've decided what type of reaction it is, we can break it down. We have hydrogen. We have oxygen. Over here we have hydrogen, and we have oxygen. Okay, so on the reactant side, we have 2 and 2. On the product side, we have 2 hydrogen. And now we have oxygen in 2 separate areas. So what we need to do is add up all of the oxygen on the product side. So we have the O2 and the O attached to H2O. And so we have a total of 3 oxygens. All right, so we have an odd number of oxygens. Again, what I would do here is try to even out any odd numbers, because you can't make an even number odd, but you can make an odd number even, and you can't balance between an odd and even. So what we're gonna do is there's a 1 on that H2O, so I'm gonna try to just put a 2 here and see how that works out. That's gonna give us 4 hydrogen. And now we have the 2 oxygen here and the O2, which gives us a total of 4 oxygen here. So now we have 4 hydrogen, 4 oxygen on the product side, but only 2 of each on the reactant side. And so let's just try to put a 2 here. That gives us 4 hydrogen, 4 oxygen. Awesome, we're good to go. So that balances this decomposition of hydrogen peroxide to water and oxygen gas. So these are some very basic examples of reactions, some very simple equations here that we balanced in these last few examples. So in class I will put up some more complicated ones and show you how to balance them so that you can get a better idea and more practice on balancing reactions.